Hello, my nerdy Nagdogs. This is week 9 of our independent study. I know you all are getting a little fatigued. Hang with me, people. This should be a nice finale and an ending to all of our science lessons. We've been talking about energy. We've been talking about roller coasters. And for this final project, you guys are building a chain reaction. Okay, so today in our live lesson, we were talking about transfer of energy. And if we were in the classroom still, you guys would be doing your final STEM project where we do car collisions and we test out how we could best build a car. Obviously, we're not in the classroom, so I've tried to come up with something else that will be entertaining. And again, the chain reaction, you guys, bring your family in, get them involved, have your siblings help you. You will have some requirements. We're going to talk about that. Meanwhile, let's get started so you can get going. Okay, so we've learned that height adds speed and distance, right? It makes a big difference. If you look at sample A, starting at this highest point should get that ball rolling all the way to the ending goal. It should power through, giving us enough speed and enough distance. If we were to start at the sample, the picture B, with the black spherical object on that second ramp, it is not likely it would make it over to the final goal, possibly. But when we think of a swing, think of yourself going on a swing. When you start out, unless you are pumping or someone is pushing you, you will never go higher than where you started from. Meaning if Kira is on a swing and she leans back and then swing, 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 it would slowly dissipate and go at a lower height each time. She would never go above the height where she started without a push or a transfer of energy, her pumping her legs. Does that make sense? Therefore, in sample B, that black spherical object is not going to go any higher than it started. The transfer of energy needs something to help propel it over that second hill, okay? So keep that in mind. Okay, what do we know? This is stuff we talked about in our live session. We know that height equals stored energy, same thing as potential energy, right? Hang on to that information. You're going to need to play with height when building your chain reaction. We also know that sometimes you need a mechanism, a push, a pull may be needed to get it to the top, to get something over the top, to again gain that momentum. Speed is increased when there is little friction. So if using something like a tennis ball, that furry substance that's around it is going to create a little friction. Sometimes you want friction to slow an item down, but friction will definitely slow down your roll. And then also the height of the first hill determines how fast, how far the roller coaster cart will go. So keep that in mind when you're building your chain reaction. Okay, what do we know about dominoes? You guys had a lot to say. You said that energy is stored, the potential energy is stored in the domino when it's upright. If it's flat on the table, there is no stored energy. There's no potential for it to move. However, when it's upright, the likelihood of it falling when has a slight push shows us that that stored energy can transfer to something else, likely another domino if that's what you're using, right? Is it possible to knock down something larger than itself? We did talk about that in the live lesson. And yes, but it depends on the weight of the first item to the next and where it lands. So something exponentially bigger than the first domino, not likely. Okay. Next steps, video and output page. You're supposed to be watching for transfer of energy. That's what your output page is going to be asking for you to identify points of transfer. And you need that for your chain reaction, right, to be successful. I want you to play with different household items. Think about how you can have stored energy and then have it released. We store energy by pulling back on tension, release kinetic energy, right? The ball at the top of the hill is stored energy with a little push or something to move it. That is kinetic energy in motion. Now, I talked about this earlier. Why did I even bring that up? Well, because if you were in the classroom, this is something we would be experimenting with, that transfer. What happens when something is transferred? So in this case, you see the black spherical object and a little gray one down at the bottom. What do you think would happen when the black spherical object hits the gray one? What does that transfer of energy look like? That is exactly what you are playing with your chain reaction. You need to test things out, okay? So that's, again, what I want you thinking about. What's going to happen when those two items collide? We were in the classroom, that would be a huge part. We would spend days testing things out, first with spherical objects, then with your vehicle that you built and driving it down a ramp. And as engineers, we would modify what we have. We don't have that. We're not in the classroom. Therefore, you guys are building this chain reaction. Test things out. Is it a big enough transfer of energy to make it go to the next step? If not, try something else. Try something smaller. Try something more upright. Try a string. Try a pull. Try tension. Try something. Test it out. Tinker. That's what engineers do. Things might not work the first time. You keep going. Okay, so I want to show you something else really cool. And it's something I did in the classroom. I'm hoping this video will work. Here we go. Just like I said, you would be testing this in the classroom. This is in slow motion. I'm dropping one sphere from the top of a hill and watch as it collides. This should give you some ideas. Here we go in slow motion. Wow, that is really slow motion. Come on, Nawg-Dawg. Here goes. Collision point. So my question would be, what did you see when things collided? Keep that in mind. Okay, I have one other video I think to share with you, if I can scoot this over. Okay, building a chain reaction. This is what you will be building today. I'm going to actually come back to that in just a sec. So bear with me, people. Okay, so before we go to you building your chain reaction ramp and lever, because that's the first part of your testing. From there, you'll continue testing with different objects. But remember, I mentioned some requirements that I will be posting next Tuesday. One of the requirements is, alert, alert. One requirement is you start with a lever and a ramp. Okay, that's why you'll be building one today. You will need to print out the two items and then you can follow the video and go from there. So let's look at our last slide before I let you go, my friends. And here we are. So what does this mean for you? Moving a little slow. Come on. Here we go. This week, you will, not that page, we're past that page, and yet it went back. Stay with me, technology. Your task for this week, watch the video and build your ramp and lever, okay? That's your starting point. Improve upon the lever in the video, maybe even the ramp up too. So you might have to improve the ramp. If you want to go with a pool table ball as you're starting and not a marble, then that paper ramp is not going to work. You're going to have to find something else. And that is okay. That's what engineers do. Modify, 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 improve. Start looking for tools you can use around your house to put into your chain reaction. Be prepared for the requirement of at least 5 different transfers of energy. Watch the how-to videos, get ideas. They show you specifically how to lay out those popsicle sticks. And it's so cool because they pop up and blow up. Why not include that is a transfer of energy. It'd be fun to see in your chain reaction. And the last one, get your family involved. Get your neighbor. I know that Addie and Jocelyn live next door. Work together on this. Wear your mask. Work together. Have fun. Get your parents involved. It should be a fun activity for all. Okay, so if this last video doesn't work, I will have it attached. Actually, I'm going to have it attached separately because it's it doesn't have any volume. So I will attach it along with your output page on the assignment. It walks you through how to build the ramp and how to build the lever. And of course, as you notice in the video, you will have to improve upon how to build the lever. Okay, my nerdy Nawg-Dawgs, you've got this. I can't wait to see what you come up with. I'm going to start posting all the how-tos. It is so much fun. And once you get going, it really is exciting. So remember, you'll have to videotape this in slow motion. It'll be due not this Friday, but the following Friday, and this is your science finale. So Friday the 29th is when I will need your slow motion video, and then I'll find a way to share those with all your classmates so they can all see your handiwork, okay? Okay, my friends, have fun. I love you. I miss you. Be engaged, be curious, try things out. Tinker, it's what engineers do. Love you.